Hello students, in this video we will be discussing about how to solve numerical problems of flotation. There are few points to be remembered before solving numericals. Pascal's principle: when a force is applied to a confined liquid, the change in pressure transmitted equally to all parts of the fluid. Pressure is equal to force acting normally on the surface or thrust per unit area. We can find out from the given formula, we can find out the value of pressure, force upon area. Force is equal to pressure into area and area is equal to force upon pressure. What is pressure in liquids? Students, a liquid in a container exerts pressure because of its weight. For example, if you try to put your finger over the end of a tap, when it is turned on, you will feel the pressure of water in the pipe. Formula for pressure in liquid is H rho G, where P is pressure, SI unit, that is Newton per meter square or Pascal, H is depth in meter, rho is density, kilogram per meter cube, gravitational field strength, that is your meter per second square. Students, before solving the numericals based on relative density, you must be having idea about the difference between the density and relative density. Density of a substance is the mass of unit volume of substance, and the relative density of a substance is the ratio of density of substance to the density of water at 4 degrees Celsius, because water has maximum density at 4 degrees Celsius. Formula for density is mass per unit volume, and formula for relative density is density of a substance upon density of water at 4 degrees Celsius. SI unit of density is kilogram per meter cube. Relative density is the ratio of similar quantities, so it has no unit. Relative density is equal to density of substance upon density of water at 4 degrees Celsius, or relative density is equal to mass of substance upon mass of equal volume of water at 4 degrees Celsius, because we know density is equal to mass per unit volume. So their volumes are same. So it means it is mass upon mass. And relative density is equal to weight of body in air upon apparent loss of weight in air, because we know weight is equal to mass into acceleration due to gravity. So mass is equal to weight upon acceleration due to gravity. As the value of G will remain the same, so it is weight of body in air upon apparent loss of weight in water. A block of foot of mass 10 kg and dimensions, means length, breadth, height are given, that is 40 centimeter, 25 centimeter and 10 centimeter, is placed on a table top. Find the pressure exerted if the block lie on the table top with sides of dimension 10 centimeter into 25, B 40 centimeter into 10 centimeter. Students, here mass is given, mass of the wooden block is given 10 kg, dimensions are given. Thrust on the tabletop is due to the weight of the wooden block. Now, weight of wooden block, that we know, that is the force. Force exerted on object by gravity, and we know force is equal to mass into acceleration due to gravity. So force comes out to be 98 Newton. Now area of site, length into breadth, that is 10 into 25, 250 centimeter or 0.025 meter square. And pressure is equal to weight upon area or thrust upon area, that is 98 upon 0.205, that is 3920 Newton per meter square. In second case, the area will change, but we know the weight of object will remain the same. So area, that is 40 into 20, 800 or 0.08 meter square. Pressure is equal to weight upon area, that is 98 upon 0.08, that is equal to 1225 Newton per meter square. A body weighs 50 Newton in air, and when immersed in water, it weighs only 40 Newton. Find its relative density. The relative density would be the ratio of density of object with respect to air and density of body with respect to water at 4 degrees Celsius. Student, we know weight is the force exerted on object by gravity. So, F1 is equal to 50 Newton and F2 is equal to 40 Newton. So, ratio of both the forces F1 upon F2, that is 50 upon 40, or we can say that is the ratio of their relative masses, because we know force is equal to mass into acceleration due to gravity, and value of G will remain the same. So, that is the relative masses m1 upon m2, 5 upon 4. And we know density is equal to mass per unit volume. Now, as the volume remain constant, so relative density, that is equal to d1 upon d2, that is equal to 5 upon 4. A solid weight 80 gram in air and 64 gram in water. Calculate the relative density of solid. Students, here the weight of solid in air W1, that is 80 gram, and weight in water W2, that is 64 gram. So loss of weight of solid in water, that is W1 minus W2, that is 16 gram. Weight of water displaced by solid, that is equal to 16 gram. So relative density is equal to density of solid upon density of water. So that is equal to weight of solid in air upon weight of equal volume of water, that is 80 upon 16 is equal to 5. A hammer exerts a force of 1.5 Newton on each of two nails A and B. The area of cross-section of tip of nail A is 2 mm square, while that of nail B is 6 mm square. Calculate pressure on each nail in pascals. Students, force exerted is given, that is 1.5 Newton, and area of cross-section of tip of nail A, A1, that is 2 mm square, or 2 into 10 raised to power minus 6 meter square, and area of cross-section of tip of nail B, that is given 6 mm square, that is 6 into 10 raised to power minus 4 meter square. So pressure on nail A, that is force upon area, 1.5 upon 2 into 10 raised to power minus 6, that is equal to 7.5 into 10 raised to power 5 pascals, and pressure on nail B is equal to force upon area, that is 1.5 into 6, 1.5 upon 6 into 10 raised to power minus 6, that is equal to 2.5 into 10 raised to power 5 pascals. The volume of a 500 gram sealed packet is 350 centimeter cube. Will the packet float or sink in water? If the density of water is 1 gram per centimeter cube, what will be the mass of water displaced by this packet? Students, density of sealed packet can be calculated by using formula mass per unit volume. So that is equal to 500 upon 350 is equal to 1.42 gram per centimeter cube. Density of sealed packet is greater than density of water. Therefore, the packet will sink. Considering Archimedes' principle, displaced water volume is equal to force exerted on the sealed packet. Volume of water displaced, that is equal to 350 centimeter cube. Therefore, displaced water mass, that is equal to density into volume, because density is mass per unit volume. So, mass is equal to density into volume. So, that is equal to 1 into 350. So, mass of displaced water is 350 grams. Thank you, students.